Welcome to today's Explainer. We're going to dive into a really fascinating dilemma straight from developer Ang's recent programming notes on refactoring Haskell code. If you write code, you absolutely know the eternal struggle we face every day. We want to make it clean, we want to make it short, and we desperately want to make it readable. But as we'll see today, those goals don't always play nicely together.
Before we look at the actual code, let's step back and ask ourselves a pretty fundamental question about balancing brevity with developer experience. Is shorter code actually always better? We're drilled from day one to eliminate every single ounce of repetition, right? Don't repeat yourself. But when we compress our logic into the absolute smallest possible space, do we accidentally create a complex puzzle for the next poor developer trying to read it?
So here is our roadmap for the Explainer today. First, the boilerplate code problem. Then, the point-free solution. Third, the readability trade-off. Fourth, reversing the flow. And finally, number 5, the flow library approach.
All right, let's jump right into part 1, the boilerplate code problem.
Picture this. You're working with a data type called export format, which represents document types like PDF, text, or Markdown. The goal is pretty simple. Get their lowercase string extensions. But the initial code handles this by manually mapping the constructors. You end up having to write out a completely separate line for every single format. Extension PDF equals PDF, extension tip equals tip, and so on. It's a classic maintenance nightmare. If you add a new format to the system later, you're forced to manually update things in 2 distinct places. It's tedious, it's repetitive, and it leaves the door wide open for typos.
Let's look at how we can fix that in part 2, the point-free solution. Okay, here comes that beautiful aha moment. We can completely wipe out those 5 repetitive lines of manual mapping and replace them with one single elegant expression. Extension equals map-to-lower.show. By leveraging show to automatically convert the data type to a string and then just mapping it to lowercase, this one tiny line handles any new format automatically. You add a new format, the function just works. No second update required. It's a real game changer.
Now, for those of you maybe a bit newer to Haskell, it's worth taking a quick second to explain how this magic trick actually works. It's achieved using what's called the point-free style. In functional programming, point-free style just means you're defining a function without explicitly identifying the arguments, or the points, that it operates on. Notice how we didn't use a variable for the format at all. We just define the operations. It's super clever and allows us to process the export format seamlessly.
But there's a catch, which brings us to part 3, the readability trade-off.
So what's the complication here? Well, it stems from that little dot operator. In Haskell, the dot is used for function composition. While mathematically it's incredibly elegant, it literally forces our eyes and our brains to scan the data flow backward, from right to left. When you read map-to-lower.show, the data is actually passing to show first, and then the result gets passed to map-to-lower. Because this goes totally against our natural left-to-right reading habits, it creates serious cognitive friction. You basically have to stop, look at the end of the line, and work your way backward. The author points out that this extreme conciseness comes at a pretty heavy price for overall readability.
Let's see how we can smooth that out in part 4, reversing the flow.
Enter the reverse application operator. By importing the ampersand from the data.function module, we can rewrite our function to look like this. Extension fmt equals fmt and show and map to lower. Notice what happened there. Actually, scratch that point-free idea for a second. We brought back the explicit fmt argument. But the massive win here is that we can now read the data flowing completely naturally from left to right. We take the format, we pass it to show, and then we map it to lowercase. That mental friction, totally gone.
Which leads us to our final section, part 5, the flow library approach.
Now, if you're open to using external libraries in your codebase, the Flow library has some fantastic alternatives that give us the best of both worlds. First up, it gives us a true left-to-right point-free approach using this neat dot greater than operator. We can just write extension equals show dot greater than map to lower. This keeps the extreme brevity of the original point-free style, since there are no explicit arguments, but it wonderfully corrects the reading direction. It just flows exactly the way you'd expect.
Or alternatively, the Flow library also gives us a super clean pipeline approach. By importing the pipe greater than operator, we can write extension fmt equals fmt isle through show, isle map to lower. This feels very similar to the reverse application ampersand we looked at just a minute ago. It brings back the explicit argument, sure, but it perfectly models that natural left-to-right data flow the developers can scan in a heartbeat.
So let's take a moment and compare these 3 refactored approaches side by side.
The traditional point-free dot operator is highly concise, no doubt, but it forces that awkward right-to-left reading direction. Then you have the reverse application with the ampersand. It fixes the direction to left to right, but you have to use explicit arguments. And finally, the pipeline approach with the pipe operator achieves that same left-to-right clarity using a highly visual, intuitive symbol. Looking at these together perfectly sums up the journey from a clever but difficult to read one-liner to code that actually communicates its intent effortlessly to the human maintaining it. As we wrap up this explainer, I really want you to think about this trade-off between extreme brevity and natural readability. We saw exactly how eliminating boilerplate is an absolute must, but definitely not if it means confusing the next developer who has to inherit your work. So take a look at your own projects today and ask yourself which syntax truly serves your team best. Are you willing to embrace new operators to ensure your logic flows as naturally on the screen as it does in your head? Thanks so much for learning with me today, and as always, keep building clear, beautiful code.